Alright guys, as promised, I'm going to go over the photosystems one more time, just go over everything we went over in class. For those of you that were here and need a little bit extra help, or for those of you who were absent and need probably a little bit more help. So we already went over chloroplasts, drew everything right in here. Just to label our areas, we have our stroma. Okay. We did the endosymbiotic theory, taught us from, I think, chapter 2, that the prokaryotic cell was swallowed up by an early eukaryotic cell, and this was the remnant of the prokaryotic cell. It has two membranes just like our prokaryotic cell, and it also has its own DNA. This would be the cell wall, the outer one, but instead we just call it the outer membrane. And then the inner one would be the cell membrane, but instead we call it the inner membrane. So we have our outer and our inner membranes. Okay. Our stroma was the liquid portion, and then these little guys that look like pancakes was our thylakoids. Okay, so that should all be reviewed for you guys. What we're going to do is, I know I taught this one way in class, I'm going to switch it just to give you guys a different view of it. It's the exact same material. I'm just going to pick a different thylakoid. In class I picked this area of the thylakoid, but today, just to switch things up, I'm going to pick that area of the thylakoid. So we're looking at the top of that thylakoid there, and that thylakoid is separated from the stroma with that little green line right there, and that is a membrane. So what we're going to do is I'm going to pull that little box out and magnify it over here, and that's where we're going to get involved with our photosystems. We're going to start off with photosystem 2, which actually happens first. So that's our first photosystem that occurs. For short, we're just going to call it PS2. All right, so that is our first photosystem that occurs. Why they called it that, guys, was photosystem 1 was discovered first, photosystem 2 was discovered second, but then photosystem 2 happened first, so they just left everything the same. So all you need to know is that photosystem 2 occurs first. So here's what happens. We know that our photosynthesis equation was we need some sunlight, we need some water, and we need some carbon dioxide. Those were our three reactants. We're only going to use two of them for this part. Okay, so what we're going to do first is we're going to bring in some water, H2O. And we're going to split that water into two different things. We're going to split it into our oxygen, and we're going to split it into our hydrogen. Okay, the oxygen, that's the same oxygen we breathe. So once the water is split, this oxygen is going to leave. Now, not just one water molecule is split, it's going to be a bunch of them, so it's not just going to give off one oxygen molecule, it's going to be a bunch of them, and it just so happens the oxygen we breathe is all bonded together to itself, so it's going to be more than that, but just for our sake, we're just going to call it the O. So this one, it's going to leave the plant, so we can breathe. Okay, so there's that. We're going to treat these hydrogens as if they're electrons. We're going to bring them in to our thylakoid membrane. But before we do that, let's label some things in here. Okay, so like I said, I'm going to do this opposite the way I did in class just to give you guys a different view of things. If we have this here, in that little box that I magnified over here, the green line would be this green area here. The area underneath that green line, so down here, this is going to be inside of our thylakoid. Okay? And then on top of the box, we actually go out of the thylakoid, so up here would be our stroma. Okay? There you go. So what we're going to do is we are going to bring in some sunlight. Okay. Okay. You guys know sunlight is energy, so that's why I drew it as a little lightning bolt. But in reality, you know, it's our sunlight. Okay. So we're going to bring that in. And we already talked about what part of our plant absorbs the sunlight, which is our chlorophyll. So I'm going to draw just a little pouch of chlorophyll in here. I'm going to fill that in. So there is our chlorophyll. Okay? All right, so the sunlight is going to hit it. We're going to pretend that up here, this is going to be a high energy area just because that's where I put the sun. And this is going to be a low energy area. And I think that'll make, help make things a little bit easier to comprehend. So these are the electrons. The hydrogen's the electrons, okay? Right now, after water is split, we have these electrons. These hydrogens don't have a whole lot of energy. So what they're going to do is they are going to go into our thylakoid membrane, and they are going to hit our chlorophyll there. Okay? When it hits the chlorophyll, we know that that sunlight already got absorbed by the chlorophyll, so those electrons are actually going to become excited from H. And what they're going to do is they're going to move to an area of high energy. So they're going to leave the chlorophyll area, and we're going to say that they are right here, and these are our hydrogen ions, or I'm sorry, our hydrogen electrons, and they are excited. Okay? After that, we now have these excited electrons from photosystem 2, and what they're going to do is they are going to take that energy they have, and they are going to come over to the stroma side of our thylakoid membrane. And let me extend this just a little bit to give myself more room. So they're going to come over to our stroma side, and what that energy is going to be used for from the electrons is to convert our ADP. Let me move this over a little bit. We're going to take our ADP, which is adenosine diphosphate. Again, we have 2 phosphates with that, if you remember from class. And we're going to convert that into ATP. Okay? So what happened during photosystem 2? Big things you guys need to know. We brought in water. We gave off oxygen. We got some electrons. We got those electrons excited by giving them energy from the sun. Those excited electrons went to the stroma side, and they converted ADP to ATP, and that's it for photosystem 2. Okay? So let me draw a nice big line here separating all of that stuff. Okay? So we are now done with photosystem 2. I'm going to erase the chloroplast over here to give us a little more room, and let's start on photosystem 1. So I'm going to draw essentially the same thing as photosystem 2, because we're still in the thylakoid membrane here. We still have the stroma side up here, and we still have the thylakoid side down at the bottom. Okay. Just draw a few of these in. So again, photosystem 2 happened first, and then over here would be photosystem 1. As we said, we still have our stroma side up here. So now what happens is we have these electrons. Remember, this is low energy up here. We're going to pretend this is high energy down here. We still have these electrons from water. These electrons are going to travel their way over to photosystem 1. They don't have really far to travel, guys. It's not that far. It's not like they're traveling miles. It's right next to it. It's just a different part of the membrane. All right. So what they're going to do is, once again, it's going to repeat the whole process of photosystem 2 with one exception. We're going to take our chlorophyll once again. So there's your chlorophyll. Okay. We are going to, again, take some sunlight. Okay. There's our energy from the sun. Yay. Okay. And that energy is going to go to the chlorophyll. All right. Our excited electron, well, not excited yet, but our electron is going to come over to the chlorophyll. Okay. It's going to get excited by having some of the energy from the sun that was absorbed by the chlorophyll, and now it's down here. So once again, our hydrogen electrons are excited. Okay? What's going to happen is after they're excited, they're once again going to go to the stroma side, which is up here. And the completion of photosystem 1 is going to be transforming NADP into NADPH. Okay? Only difference between photosystem 2 and photosystem 1 is that one difference, photosystem 2 forms ATP, photosystem 1 forms NADPH, and also photosystem 2 involves the splitting of water to get those electrons, those H2s out of there, but photosystem 1 just reuses those electrons from that split water. We do not add water into photosystem 1. Okay? So we just, like, again, I said, reuse it from the water in photosystem 2. All right? One more thing I wanted to say, guys, about this. All this happens in the thylakoid membrane. Our next part of this, the Kelvin cycle, happens in the stroma. For the Kelvin cycle, this is where our CO2, remember we said photosynthesis needs sunlight, it needs carbon dioxide, and it needs water. We use the water here, we use the sunlight here, which is why these are going to happen during the day when it's sunny outside, but we didn't use any carbon dioxide. That carbon dioxide is used in the Kelvin cycle. Also, other things that are used in the Kelvin cycle are the ATP and the NADPH, which is why these are formed on the stroma side. The Kelvin cycle occurs in the stroma. That's why we formed them on those sides. If we formed them on this side, they would have to travel all the way across our thylakoid membrane and go into the stroma. It's much easier just to form them over here. That way they can be easily accessible by the Kelvin cycle along with our carbon dioxide. All right, hopefully this helped, guys. See you tomorrow. Have a good day.